Hey guys, this is Professor Janacek. I want to go over an example where we find the volume of a solid of revolution. Remember that volume we'll consider as area times thickness. So let's determine the volume of the solid obtained by rotating the region bounded by y equal to the square root of x minus 2 and y equal to 2 in the first quadrant about the x-axis. I've gone ahead and graphed that here. You can see y equal to the square root of 2. It's y equal to the square root of x minus 2 is this line right there. Y equal to 2 is this line up here. And being in the first quadrant means it's also bounded by the x-axis and the y-axis. And let's see, we are rotating, so our figure ends up being this bit here. That's where all our bounds are. So we're looking at inside of that. And we are going about the x-axis here, so you can see that we end up with these circles and this the full image there. Okay, so let's see. We are revolving about the x-axis. You'll notice I also have selected a piece here to analyze. This little bit I chose mainly because the graph, this image here, kind of is longer in the horizontal direction as opposed to in the vertical direction. It's kind of short vertically, but it's longer horizontally. So I picked that as our little piece to analyze. You'll notice that little piece is parallel to the x-axis. And if we look at our notes above, revolving about the x-axis, parallel to the x-axis, it looks like we are going to integrate with respect to y. And we will use the area to look like length times width. Of course, if you recall going over this method, the length is really the circumference, and circumference of a circle is 2 pi r. So we'll use 2 pi rw. So let's see. To find our volume, we will want to integrate. Again, it's the area times the thickness. And remember that the thickness, since we are integrating with respect to y, our thickness we will denote as dy. That's that little differential. It's an approximation of delta y. So we end up with the integral of 2 pi r w times w delta y, or dy. Okay, so we will need to figure out what is that radius and what is that width. So let's see, the radius, in this case, if we look at the circular form, you'll notice that we form circles this way. There's a nice pretty circle to look at. The radius of that circle would be measured as a y value. And of course, moving along the figure, it might be a difference. It might be a different lengths, but it's always that y value. So our radius is y, and the width of this piece, right? What is that distance there? Well, that is defined by our curve, square root of x minus 2, and y equal and the y-axis. So that's how we'll figure that distance. Of course, square root of x minus 2 minus 0 is just square root of x minus 2. So our width comes from y equal to the square root of x minus 2. However, remember we are integrating with respect to y, right? We've already determined that. So we'll need to write this as a basically write x as a function of y. So if y is equal to the square root of x minus 2, then x is equal to, is that y squared plus 2. So that's what we're going to use for our width. Okay, so let's see. Our volume is the integral. Now this is a definite integral. Since we are integrating with respect to y, what are the y values? Well, the y values go from 0 up to 2. So we're going to integrate from 0 to 2. And then we have 2 pi times r. We've already decided that the radius would be y. And then our width in terms of y is y squared plus 2. Okay, well, there we go. I can factor out that 2 pi if you'd like. You don't have to. You're welcome to, but it's not necessary. And actually, I'll also go ahead and distribute the y inside that integrand. So we have y cubed plus 2y. Oh, polynomials. We love integrating polynomials. Yay. Just don't forget we're integrating, not differentiating. So often I see people go the wrong direction with this. Just take your time with it. That would be, let's see, if we integrate y cubed, that would be 1/4 y to the 4th. If we integrate 2y, we end up with y squared. And we're going to evaluate this from 0 to 2. So that's 2 pi times 1/4 times 16 plus 4 minus 2 pi times 1/4 times 0 plus 0. Do some arithmetic there, and let's see, we end up with just 16 pi. There you go. Remember, this is a volume. If it had units, those units would be cubed, but we don't have any units in this situation, so that's all we need. Enjoy!